Welcome students. Today we will discuss about the important questions for the NEET 2024. So starting from the question first, calculate the torque of force 5 iota minus 2 j cap plus k cap about the region which acts on a particle whose position vector is this. So as you know, torque is denoted by tau and the formula is r cross f vector. So as you know, r vector is given in the question equals to I cap plus j cap minus 2 k cap, and f vector is given as 5i minus 2j cap plus 5k cap. So according to the formula, when we put these two parts in this formula, and we will get, firstly you know, as it is a cross product, so cross product can be solved in this manner. Firstly you write I j k cap. Firstly you put the value of r vector. It is 1 1 and minus 2. The value of f is for the I cap 5 coefficients minus 2 and capital 5. As you know, to find the cross product, firstly we take the vertical I and horizontal I. We cover this by this way. So we will get, by covering these both, multiply by I 1 multiply by 5 minus 2 multiply by minus 2. It becomes positive, but the sign becomes negative in the center. So we will get 4. Now plus minus j cap, by covering the horizontal and vertical for the j cap, it becomes 1 into 5 minus minus plus 5 to 10 plus k cap, by covering the k section, minus 2 minus 5. On solving 5 minus 4 minus j cap 5 plus 10 plus k cap minus 7. Now we will get here I cap minus 15 j cap minus 7 k cap. This value is the value of torque but is in vector form. We will calculate it is in the magnitude. So by calculating by the mod, which is 1 square plus minus 15 square plus minus 7 square. After solving this, we will get 1 plus 2 to 5 plus 49. By adding this, we will get 2 to 6 plus 49 and 6 plus 9 15, 7 2, and we will get the value of, or the magnitude of the torque is root 275, and from the option we will get the answer B is correct. Now moving to the next question. The question is, a particle moves along the x-axis from x equals to 0 to x equals to 5 under the influence of the force which is given by this value. Find the work done. Now as you know, the formula of work done equals to F dot ds, but in this question the value of x ranges from x equals to 0 to x equals to 5. This is the small work done. When we calculate the whole work done with the limits x equals to 0 to x equals to 5, we need to integrate. Okay, so the range here, the value for the displacement, this is a displacement, but in this question the given displacement by represented by the small x. So my new formula becomes f dot dx, which is equals to dw. Now the value of f, which is given by 7 minus 2x plus 3x square dot dx, and the limit x equals to 0 to x equals to 5, and the integration of dw becomes w. Now when we integrate, as we know, the formula for the integration is this: x raised to power n dx equals to x to the power n plus 1 upon n plus 1. Now by using this formula for of the integration, we calculate 7x minus 2x to the power 1, which becomes 1 plus 1 upon 1 plus 1, becomes 1 plus 1 upon 1 plus 1, plus 3x 2 plus 1 upon 2 plus 1, which is equals to w. Now w equals to 7x. The range is also needed to mention here. Now 7x minus 2x square upon 2 plus 3x cube upon 3 within the limits 0 to 5. Now we need to firstly cancel this, and now the w equals to 7x minus x square plus x cube. Limit becomes this. Now we put the upper limit, then lower limit. 7 into 5 minus 25 plus 5 cube 125. Minus, when we put the value lower limit is 0, whole becomes 0. We will get 35 minus 25 plus 125 becomes 35 plus 100, it becomes 135. So the work done, which is come the answer 135, and the unit is joule. This is the answer. When you see the options and you find 135, you need to correct it. Now moving to the next question. The question is, a particle executes SHM of amplitude 30 cm and time period is 4 seconds. What is the minimum time required for the particle to move from mean position to a point 15 cm? Now, as you know, the formula is y equals to, the displacement equation is y equals to a sine omega t. Now, y is the displacement, and here mention the amplitude is 30 centimeter, means the value of a is given is 30 centimeter, and the position is 15 centimeter. Now we need to put here 15 and sine omega. As you know, omega equals to 2 pi by t. Now put this value here, 2 pi by t. Now according to the question, we need to find here is there small t. What is small t? We need to find here small t. Now 15 equals to 30 sine, the value of capital T is also mentioned in the question, which is a time period 4 seconds. Now 2 pi by 4 multiply by t. 15 divided by 30 equals to sine 1 pi by 2 t, and this become 1 by 2. Now 1 by 2, which value of the sine has the value 1 by 2? Sine 30 equals to 1 by 2, which is also when we written in the pi form, which is pi by 6. So as similarly we write here sine pi by 6 equals to sine pi by 2 t. On comparing, we will get pi by 6 equals to pi by 2 t. By cancelling, we will get 2 by 6 equals to t, and we will get t equals to 1 by 3 second. The answer becomes first. Now comes to the next question. A stone weighing 3 kg and tied to a string is being rotated in a horizontal circle of 120 cm with a velocity of 500 meter per second. Find the total force which tries to break the string. From the question, it is mentioned here the mass given is 3 kg, means mass given is 3 kg. Is tied to a string, means here the mass which is noted by small m and the value is given 3 kg, which is tied to a string. Now is being rotated in a horizontal circle of 120 centimeter with him, means the radius is given is 120 centimeter with a velocity of, means the velocity is given here 500 meter per second. Now we need to calculate the total force which tries to break. As you know, when it rotates, it tries the force which is centripetal force. Now the formula is, of the centripetal force is mv square by r. By substituting this value 3 into v square by r. R is 120 centimeter. We need to convert it into standard. 120 divided by 100, which means 1.2 meter. 1.2. On calculating this, we will get this value. Now, from the option matches the second. But here 625. By calculating this, so sorry, this is 625. There is a correction. This is 625,000. Now this option.